nobody here. Should I shut the door and do shame again, or has everybody gone for legitimate reasons?
Class hasn't started yet.
It's 8:14. It might as well have started. You're supposed to be seated with your notes out at 8:15. Then they are within 30 seconds. 30 seconds.
And they're cold. They're staying out.
God, I hate Octa.
There's some.
No, we already finished everything.
No, it's the other cabinet, isn't it? The ones, yeah. The portion left. It's not. No, go to that one.
Yeah.
I'll do it later. We'll do it in post.
No, they haven't came out yet. You? Oh, let's see you apply.
Wait, Mr. Can I fill this up? Really quickly? Really quickly.
Yes. Although you're late. Gentlemen, you're late. The bell is at the point at which you should be seated with your notes out ready to go. Whew. That's the wrong one. Yes.
That's too good.
There's the light bulb.
You're right.
There you go.
Did you go and watch the highlights?
No. I was on Thursday. Bro. Why did Eli not go?
Andrew. He's being Andrew.
Someone took it.
Wait, did we get a new note?
If you did not get the notes packet from last week,
No, I got it.
it is right here. Don't touch the chemicals.
I got one of those. M&P.
Yeah. This is like this is this one, right?
Yep.
Oh, whoa, whoa. You can't do that. You put your thing down. Are you serious? You're not. You can't alter the game. Absolutely do.
Can you scroll up to strong acids?
No. Okay. I'm going to show you how to do the first one. I'm going to have you do the other ones. Maybe go build a board. Weak acid and notes part. I think this refers to a previous one. Strong acid and strong base react 100%. They have a one-way arrow that goes like that because you get 100% ionization. Yes? Yeah, they're over there. I already said, let's go, let's grab them. Whereas if you're a weak acid and a weak base, you do not have a one-way arrow. You have a two-way arrow. You have less than 100% ionization. It's usually much less, but technically, as long as it's only 99%, 1% not ionized would count. What we call by ionization always involved reacting in water. So I'll do the first one. Strong acid, if you have HCl and it's a strong acid, what kind of arrow do you use? One way. So HCl plus H2O goes to and makes
H3O Cl.
H3O
Plus. Not plus.
plus
Plus.
plus
Cl minus.
Cl minus. There you go. Oh, it's colorful now. Go up there. Everybody write an equation. One writes one equation with the other's help. The other writes the other equation with the other's help. So everybody writes an equation. There you go. Burners, windows.
He's not.
I got a lot of that.
You're running way too slow.
Hey. First come, first serve.
Once you've written it, have a seat.
Oh, wait.
I'll take just casually handling the Privet Trophy for international
HI.
rowing.
Plus H.
Notice Ellis won in 2016, and then I know a bunch of houses won it between 2016 and 2024, but nobody bothered to get their plaque on there.
Pretty sure there was.
And then Ellis won in 2024.
Pretty sure because there was no crack.
There was between 2016 and 2024. There was a number of years there wasn't, but there was. There was definitely one in 2017 and 2018.
Oh. Okay, wait.
So we're gonna get our plaque on there.
Yeah. Okay. Or down.
Not balanced.
Not quite. Is that yours on the top there?
No, the bottom one.
Bottom one? Oh, that one was better.
The
Yeah, good.
H2
Yeah.
and then HI.
Yeah. Oh, good. Charges are
Below
going up.
Isabel's.
Yeah.
Okay.
Why is the H and SO4 so far apart?
What do you mean?
There's.
Are the two of ours good?
Where's your
Those were me and Naomi were the two.
bottom right?
Yeah.
Yeah, those are good.
Those are both good.
Red irons.
Your handwriting's kept.
Excellent. Charges. Charges.
The charges are on there.
Charges. Excellent. Charges. Charges there. Charges. Charges. Yeah, charges. And nobody made the second most classical mistake. Yes.
Can I go aside to receive the SMS?
Oh God, yeah. Hate that. Okay. I will quickly duplicate all of your hard work. Like AI is doing. Oh, did I check arrows? Arrows. Arrows, 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 arrows. And arrows. Excellent. Evan, take the bug out of your. For all of these, you react with water first to get H3O plus. As we know, H3O plus is the same as H plus, but there are times in which, to show the equilibrium properly, you can't be as easy as this. I mean, that's still acceptable, but to show ionization, we're showing why it becomes ionized. It's donating into water, and we're doing the real part. And we need one-way arrows. Also, nobody made the mistake. In grade 10, it's very common you take the second H off. You only do that if it's reacting with something strong. It's strong, it reacts with water, but once you get to there, this one's weak, and it doesn't go, and everybody did that automatically. Well done. Okay, those 4. These ones are weak.
There's
So,
what are the charges for the bottom 2?
I'll go back in 1 second. Charges for
Scroll up again.
scroll up where? What?
Back to the other one.
Oh, the bottom one? Oh, someone was asking about the charges on these ones. Everybody done with this one?
Oh yeah.
Oh, excellent.
I was trying to see if
Then find your people, go to the board and do those 4. Erase what you had before
You still put them with water.
and do these ones. You still put them with water. Thanks for putting it away.
Well, I feel like, okay.
There is one major difference.
Oh yeah, I already know. I was just yelling.
He already knows. Oh, and just to allay any fears that you may have, I may sneeze on you, but according to a doctor, I am no longer infectious. Huh? You can be in the splash zone.
No, thank you.
I don't like that at all.
I'm no longer infectious.
But if
And
you're
I-
coughing.
Oh, I'm coughing so much.
Yeah. So that's what determines if we put a mask on.
What? No. No. Why do you think I got so sick? No student wears a mask.
Yeah,
They
but
come
that's
up to
what
me and
they
say,
do.
Mr. Neufeld, and then cough right in my face. Can I have a health center now?
Yeah.
Yeah.
I mean,
Yeah. So
that's
I
what
did,
this monkey said. So as long as they get.
but the cough is now from the inflammation and irritation. It's not from the virus. Apparently.
So then SO4 is 2 marks.
No. Got to teach. I took more sickness in a row than I've ever taken in this years.
Is that writing?
Oh, it's beautiful.
I know, I'm kind of good.
It's beautiful. What? What? Why does that not have? Oh, okay. Good one.
Where's the middle class?
Everybody got the first one? It looks like everybody's got the first one. I'll just catch up.
That just makes it worse. Okay. You added water, but water just takes water. I think you just get more water.
Nice. Ooh, that's good.
Because they have to add up on both sides.
Okay, basically. Well, yeah, well, that's. Come on. Yeah, come on. She didn't finish her 6 She said yes. it's just like, if you want to, you could, but it's not an issue. If you appeal it, then it's just like, unless you, and then you should appeal it. Cause that'd be like,
I know.
yeah.
Like,
If you
Joel's talking about
lost
like,
your series, so like 1 to 6K.
should have like.
1 to 6K, and then the like 2K, basically.
Where it's like,
You're not
But there's never, it's not just on water.
I would say consent of bodily fluids is the second most
It's just
important
like,
technical
it's
consent.
I don't know why do you, if you know why do you gotta email? Why
It would be like Novella just automatically.
Excellent, last one done.
Yeah, because she in a different sphere. Everyone competition levels, yeah. So it's also like, but then again, do you want it seriously just to like professional? Yeah, but it's kind of nice because she's like a good benchmark, you know? Like, just like, there's like the end of the year.
Yeah. Say like Joel's.
Oh, so you can see how much I'm doing. Yeah. But bro, so anxiety is wrong. She said she wanted to go
Angel will have a cover.
It also like doesn't matter. She said she felt good.
Well, that was
Yeah, it was better.
From what I can see, all the arrows are correct. They should all be two-way arrows. It looks like they all are. And also, I guess not surprisingly, everyone correctly said, oh yeah, we do have to react two waters together. This is why the pH scale is not an arbitrary scale where we just said, oh, 7. We'll make that the middle. The reason is because in a solution, when you allow this to go at, I think it's 25 degrees Celsius, you get 1.0 times 10 to the minus 7 moles per liter of hydroxide, and 1.0 times 10 to the minus 7 moles per liter of H3O+. We'll be doing that in detail later when we do calculations, but the pH of 7 is the middle because when it's just pure water, I've told you before, water is covalent, it doesn't ionize, and that's a tiny lie. It does, it's just it ionizes to this amount, which is so small it's not going to conduct electricity, so it's not considered an electrolyte. But it does it a little. Why is it neutral if you have acid around?
Because it's like already paired.
Pardon?
Wait, never mind. Say the question again.
Why is it this solution considered neutral even though you've made acid? There's two of the same things?
What's the pH level still 7?
If the pH level is 7, but there is, if I asked you, is there acid there? The answer would be yes. It's not because there's no acid. Why is it then neutral?
So it's weak enough?
That's all I knew what the term was.
You can actually lower the pH, make it more acidic, and it will still be neutral. Neutrality can be at a pH of 6 if the water's hot enough.
Is it because it's at 12?
Nope. It's this amount. So pH of 7 is neutral only at room temperature water. Increased temperature water actually becomes more acidic. Ooh, throwback to equilibrium. If it becomes more acidic, as in it shifts to the right with an increase of temperature, is this an endothermic or exothermic reaction? Hmm? You're confused. It's okay. If it shifts to the right, so it becomes more acidic, is this with an increase of temperature? Which side is the energy term on? If it's shifting that way, and we raise the energy, so when this goes up, then it shifts that way. The water becomes more acidic, but still neutral with an increase of temperature. You could have a pH of 6. I think you can if you get it hot enough and it's not quite boiling. It might actually be only 6.5 or something. However, why is it still neutral? We're gonna have a council to decide the fate of who wins Interhouse. The only people allowed to attend are Privet and Hope students. Is that a neutral body?
Yep.
Excellent. One vote?
No,
No, why is it not neutral?
this is only one part there.
Only one part there. What other parts would have to be there?
All the other houses.
All the other houses. Do they all still have biases?
do.
Yes. But if you have equal representation, then hopefully those biases cancel out. What also does it have in addition to acid?
Base.
Base. How much base?
The same amount.
The same amount. So then these are equal, therefore neutral. And I know, and I mentioned this early because I know in grade 10, some people, especially if they weren't taught here, will have been told that there's no acid at a pH of 7. The water is neutral because there's no acid present. There is acid present. It's just present in equal amounts to the base. So a pH of 7 is a measure of the acidity. The acidity is 10 to the minus 7. A pH of 8 is 10 to the minus 8, and that's considered basic because the pOH will be 6. But that's a joy we will save. Oh, wait a minute. Devin. Turn this way. And grab the lights. The other thing is, oh God, I need curtains. You can't make the classrooms dark anymore. Make classrooms dark again. Okay, this is one of my most hated demos by me, students. Because growing up, and still, whenever I do an experiment, I end up shocking myself half the time. Crippling Farm, they had electric fences. Any of you ever been near an electric fence?
Yeah.
How many of you have touched an electric fence?
Yeah.
How many of you had parents that said, can you go rehook that fence? Is it on? No. And then grab the fence thinking it was off and it turned out to be on, then you turn around and everybody's laughing at you. To be fair, I immediately did that to my younger brothers, so. Make sure it's nicely rinsed. And this is the demo I should have done the first day. But half of you were gone. I just discussed it, so you see the results we should get. So, we will start off with pure water. Those of you who were here the last day, don't say anything. Pure water. Jump in a bathtub, throw in a toaster. Should you jump in?
No.
No? So, will pure water conduct electricity?
Yeah.
Pure water is a covalent compound. Does it conduct the electricity? No. No ionization. I mean, that's a lie. I just showed you the ionization. But it's so small. Essentially, covalent compound, no ionization. It's not going to conduct. There's not enough ions to conduct. Conducting requires a certain concentration. So that's pure water.
So you wouldn't die with the toaster.
Ah! Yeah, you would. Because what does water require in order for it to conduct? Ions.
Most of your body.
Yeah, your body's full of ions. You're sweating all the time. As I mentioned the last day, your sweat is the equivalent of urine. It has urea and salt and all the sort of stuff that your pee does. However, it's just a lower concentration of urea. So that's why the white shirts and the underarms will go yellow over time because literally urea is making it go yellow, and you can get bluing agents for your laundry. Here is sugar water. Should sugar conduct? Why would sugar conduct? Again. I mean, Marcus said, yeah. So, Marcus, explain. Sugar? What ions in sugar? Is sugar organic?
Yeah, it is.
Is it an organic acid? No. So organics are not connected. That isn't. You need ionic salt or some sort of thing that's going to ionize, like an organic acid. Sugar is neither of those things, and so it's not going to conduct. I will now rinse this off. And rinse it out. So let's go straight to the obvious one. 0.1 molar HCl. Should it conduct? Okay, so all that demo. I swear, I just did it out in the lab. It's on here. And now, I have to redo all of them. It wasn't plugged in before, so that was a lie. The reason it didn't go on is because we didn't have it. Okay, pure H2O, no conduction. Pure sugar, well not pure, concentrated. 0.1 molar actually. And now HCl. 0.1 molar HCl. 0.5 molar HCl. Should we conduct more or less?
More.
More? So 0.5? 0.1. Is there a difference?
Yeah, a little bit. I see different.
There's a little bit.
There's definitely
I don't know if it's 5 times the difference. And one of the reasons being is that at a certain level, it's just conducting everything. If you have a really thick wire and a medium thick wire, but the amount of current can fit through both easily, it's not going to make a difference. It's only when you have not quite enough that it starts making a difference. And so, yeah, the 0.5 should be a little brighter. It usually is. But the difference is a little subtle. And if you don't believe me, that's fine, because it is a little subtle. And maybe it's not there. Maybe I just convinced you. I did used to do that biology demo with mint and diffusion. Does anybody still do any of you in biology AP? Do they do the mint diffusion demo? Takes a little green bottle, puts it on the desk, and then you put up your hand and you can smell the mint as it wafts through the room. Yeah, it's usually green colored water. And there is no smell, and you're just using the power of suggestion. Okay, this is 0.1 molar citric acid. Should this conduct more or less? More. More? Less. The same?
Then what?
Then the 0.1 molar HCl. So, reference, 0.1 molar HCl. And now I have to rinse it again. Yep. Yeah, that was. Now, 0.1 molar citric acid. More, less, same. Less. Why is it
Weaker acid.
weaker? So what is the difference between the two equations?
That's
That's equilibrium. So when you wrote up the equations, what was the difference between the 100% and the weak? Yeah. It has two-way arrows, so most of it is sitting on the side without the ions, just sitting there. And so this is just a little tight. So same concentration. It could neutralize the same amount of base, because the base would react with the acid, which would shift the equilibrium, which would react with the base, which would shift the equilibrium. But just when it's resting, it's just on the wrong side, so it doesn't conduct. And so the fewer amount of ions you have, the less conduction that is possible. And so ionization is a measure of the strength of the equilibrium. The brighter it is, the stronger the acid would be. I think I tried to find vinegar this morning. I haven't shocked myself yet. If you're ever working on electrical in a house, why should you do it with your arm behind your back? As in, you were working like this. Pardon? Yeah, because what's in between both your arms? Your heart, which, as everybody knows from TV shows, when you zap that, it can stop and start working. You definitely don't want to stop it. At least if you have one arm behind your back, it might go here down to your leg, which is how you survive a lightning strike. So that corresponds to the results I said. 0.5 should be a little bit more than 0.1. They're both 100% ionization. The 0.1, even though they're the same, less, because you have a two-way arrow. And what you have is strong acid, HCl plus H2O goes to H3O plus Cl minus. What is the concentration of ions if this is 0.1 molar?
Wait, what?
What is the concentration of all ions?
Of 0.1.
No, you're close. You're just thinking a little too fast. Slow down. Concentration of all ions on the right. 0.2. Because if this is 0.1 and all of it reacts, how much of this do you get?
0.1.
0.1. How much of that do you get?
0.1.
0.1. So 0.2. It's concentration of all ions. If you have citric acid and, I don't know, C something, let's do it like this. HC, who cares? Plus H2O goes to C, who cares? Minus 1 plus H3O plus.
It's a question mark.
It's just a question mark. If you have 0.1 molar of this, how much of that do you have?
0.1.
No, it's not 100%. It's a two-way arrow.
Oh, 0.5. Wait,
More?
What? Wait.
You
0.05.
created- Point.
Is that
Why?
half of 0?
Why 0.05?
Because half of it's going to equilibrium and half of it's getting shot back.
Why half?
Because there's two. They each can go
PbSO4 goes to old school. We just did this. Pb plus 2 plus SO4 minus 2. You have a KSP of some kind for that. Calculate the concentration of ions in solution. How would you do that? What is the KSP for PbSO4? Data tables you'd need. Data tables. Vapor late. The same things you did in solubility you're going to end up doing in acid or base. I just picked it. I'm assuming there's a lead sulfate on there. Lead 2 sulfate.
1.8 times. Oh.
1.8 times
10 to the negative 8.
10 to the negative 8. Excellent. That's tiny. Calculate the concentration of ions. What would you need? How would you do that? Yeah. X squared over X. Solid.
X squared over 1.
Yeah. So what you need is the solubility. Because if the solubility is X, you'll get X and X. And same for this. Then you will need X squared equals 1.8 times 10 to the minus 8. This is KSP. Take the square root of both sides. Yada, yada, yada. And you will have a number. Is it 0.05? If this was a 0.1 molar solution?
No.
No. So same here. What number do you need in order to calculate how much is going to be on the other side?
KSP.
Yeah, the KSP. In this case, it'll be called the KA or something. And so the amount. So it'll just be small. It'll be less than 0.05 most likely. It'll be a really tiny number times 10 to the minus something. And you'd have to calculate it out. And so the amount of ions coming off are really quite small. However, a weak acid is just as capable as a strong acid of neutralizing base. If I give this 0.1 molar NaOH, and I give it the same amount, it can still react with all of it Because if I put base in the solution, what does it remove from the system? Of this equation, what does base react with?
Acid.
Which one's the acid?
H2O.
Nope.
What?
Pardon?
HC question.
Nope. That is what we call the acid, but what is truly the acid in solution? What's doing the stuff that reacts with other things? What do acids give off back from grade 10?
H.
H plus. Which one of these is actually H plus?
That one. What? H.
Yeah.
H3.
That's H plus. That's H plus. H plus plus OH minus makes water. So if you add base to this, it will drop that concentration. What will happen to the equilibrium? It'll shift that way, and it will keep doing that until it's done reacting with it. So it will all still react. It's just when it's sitting in solution, it won't react, and it doesn't ionize as much. And so it's not as immediately dangerous. You can put vinegar on your fries in a low enough concentration and eat it, and it's not like putting HCl in your fries and then eating it. However, you can get vinegar strong enough that it will burn all the skin out of your nostrils. So do be careful. Okay, strong base versus weak base. I want you to do here exactly what you did for the acids. And I'll just get these set up as well, but we won't do them right away. So grab your party time, friend. So, for the first three, grab your friend, erase what's on the board, do the reaction the same, almost the same. One of them is a trick, as you did previously. Nice. Don't let them. Yeah. Don't let them do that. Also, out of respect, we can pull this table back and give them more room. Woo! Same as last time.
Oh, no, we add one. There's no way I'll like your strong base.
I feel like you want to know that.
Yeah, that would become NH3.
Nice.
Plus the
Yes.
two.
Yes. And one of those ones. Right?
I would like to remind you that these are bases,
Yeah.
and you're making HCl plus, you have decided it's an acid. These are bases. Bases. Never drop them. Never drop the base.
NaOH.
we were using acids. This is your equation for the acid. You want to do the same, but get the opposite. So you start the same, but you should get the opposite. What is the definition of a base? Well, yeah, but it's OH. OH. Minus 1.
Mr. New, can we see the questions?
Check against another group. I'm going to go around and see.
We need the last.
Wait, Nick, can you go back really quick?
It's right there.
No, that's not the right one.
Oh, right, that one. Sorry. There. There you go. Sorry.
Oh, NaOH, no charge?
NaOH is no charge. That one's a trick, by the way. That one is a legitimate trick. Nope. I am going to check, but only when I go around and muck them. Nope. Endless. Endless? See what that does. What are you reacting it with? What did you react it with when it was when we did acids? H2O. That's the only thing that's around. Yeah, first one's right. Second one. I didn't say that. And last one is weird. The last one is a trick. You should think solubility, not at basis. Once you're done, have a seat. If you're reacting it with H+, you are not doing what you're supposed to be doing. It doesn't react with H+. What are you reacting it with? There's no H+. You just got it in water. What's the only thing around? H2O. Excellent. H2O. Pete, don't look at me like that. Put H2O in. Fix it. There you go.
What?
Kevin, you got it's like third time. No, you're here. Yeah, you can't. But that doesn't undo that. Playing? No. Oh. Can you hear something?
I can't hear anything.
Drops ever.
I'm trying to listen for it. I can't hear it.
Check
It's so quiet.
in the bottom corner where there's like the green. Oh,
What?
never mind.
Bottom corner.
Like, yeah,
Check what it's playing from. Check, check.
oh, yeah, that one.
Really?
What is it?
This web browser. Also, this is on Oh, this is on my laptop.
Yeah.
Half the time it isn't properly connected to that speaker. That's annoying. You can get endless reverb type stuff, and it never drops the bass. Mm. Your last ones are weird. No, the last ones are weird. Think solubility. All your other knowledge can go away. That one's still weird. Does that one say Rick? Trickster. I see. I'll show you the last one. Don't panic. Okay. What are bases? Matt. Chemistry focus. Starting with acids. In terms of protons, what are acids? Matt, what's an acid?
What is an acid?
Yeah.
Acid is something with hydrogen
It's in terms of protons. It's a proton. Gives them. Proton donor.
So pH lowers the
That means a base is a proton
Receiver.
acceptor, receiver. So this is going to accept a proton. So what will happen to the number of H's?
It'll increase.
It'll increase. What will happen to the charge?
It'll decrease. No,
Increase. H plus. So it'll go up by 1. So that goes from -1 to 0. This one gives up a proton. What happens to the number of H's?
Goes down.
Goes down. We also write it as OH because it'd be weird to write it as HO. It's like strange Santa Claus. And then what happens to its charge? Charge is 0, so its new charge is minus. So same thing you were doing before with the acids, except now we're moving the proton the other way. These are bases. They're a proton acceptor. So we go, when we get H minus plus that left, OH minus. So you got 2 OH minus.
Did you just do 2 OH?
You can, yeah. You just balanced it. I'm just showing it to see where it goes. And then this one, this is a solubility equation. It's a strong base, but it doesn't react with water. It just is 100% soluble. So in acids and bases, there are still solubility equations. Why is this all of a sudden louder? And that's not what I thought it was. It was supposed to be an endless reverb in which the bass was never dropped. It sounds like a garden stream. So you will see this, and on a test or a quiz, there's going to be the strong temptation to react with water and do the same thing that you do all the other things. Resist the temptation. This is a solubility equation. You will get some amount of it. Let's say it's a 0.2 molar solution. Then this just means it's 0.2 molar solution, and you take that hydroxide and do whatever else the question asks of you. Do not treat it like a regular one. Weak base, now that you've seen that, now you should be able to do those no problem. No problem at all. Group maker 2. Go gadget machine. Okay. Let's go now.